Ignition sequence start.
Good morning. You've got a look here at the activity inside the International Space Station Flight Control Room at NASA's Johnson Space Center. There's a team of experts here 24/7 to oversee operation of the station systems in orbit and assist the Expedition 65 crew members with their work on board. This week, Commander Aki Hoshide and his crewmates spent time digging into the tons of supplies delivered on the latest cargo ship, while also getting ready for a spacewalk that is the first step in the installation of another set of new solar arrays.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Sandra Jones. This week, the crew unpacked and began science investigations that arrived on a cargo vehicle, and 2 astronauts are about to head out the space station hatch for a spacewalk. Last week, 4 tons of supplies and investigations arrived to the orbiting laboratory on the Northrop Grumman CRS-16 cargo craft, and the crew has been busy unpacking the vehicle and getting started on the science inside. One of those science experiments, the Cardinal Muscle Investigation, tests whether microgravity can be used as a research tool for understanding and treating muscle loss on Earth. Expedition 65 Commander Aki Hoshide worked this week on the cell gravasensing investigation, which studies how cells can detect gravity and changes in tension during spaceflight. The ring shear drop investigation studies the formation of potentially destructive protein clusters like those found in patients battling Alzheimer's and Parkinson's. Ring shear drop uses the surface tension of the liquid specimens to act as the container for the experiment. To learn more about all of the science and research happening on the space station, follow us on Twitter at ISS_research. 2 astronauts will take a break from science to step out into the vacuum of space. On Tuesday, August 24th, JAXA astronaut and current space station commander Aki Hoshide and NASA astronaut Mark Vande Hei will suit up and venture outside the hatch. During the spacewalk, the duo will build and install a bracket that will be used to attach an ISS rollout solar array, or IROSA, in a future spacewalk. Because of the size of the bracket, it is sent to space in pieces and assembled in microgravity, similar to how we put together furniture here on Earth. The crew will also swap out parts on the floating potential measurement unit to ensure it can provide readings for years to come. We'll be covering the entire spacewalk live on NASA TV, the agency's website, and the NASA app. Tune in beginning at 7 a.m. Eastern Time to check it out. Also, be sure to watch our coverage of the upcoming launch of the SpaceX cargo resupply vehicle, blasting off from Launch Pad 39A at the Kennedy Space Center in Florida. CRS-23 is slated to launch on August 28th and will be packed full of supplies and science investigations with a ticket to the International Space Station. And that's Space to Ground for this week. Thanks so much for watching. We'll see you next week.
As we travel farther into space, clever solutions to problems like stocking spare parts will be a vital part of NASA's preparations. 3D printing is an emerging technology that may be used to create custom mission-critical parts. But first, we must understand how particle shape, size, and distribution affect the manufacturing process. One particular study is helping to explore these factors.
One of the things they're going to have to do for space exploration is do additive manufacturing, because we may have an engine part that fails, and you're certainly not going to take up spare engine parts. You're going to have to manufacture them there. And a lot of what we want to do with that means looking at microscopic particles, because they're building blocks. And now I think a big part of the future in this field, and for lots of different reasons, is active materials. So now we have ways that instead of just the particles being just particles, we can activate them, we can functionalize them, we can get them to associate with one another specifically. So one of the things we're aiming for is active self-replication, evolution in microgravity, to put lots of things together and to optimize properties using evolutionary processes from not living things. but mimicking what living things have done so successfully. We'll learn how to do that on Earth eventually. But before we do that, it's much better, because they have different densities, to do it in microgravity. It's always really important to do something at the forefront of science that will then become a forefront in engineering and production.
A tool that helped guide sailors across the oceans for centuries is being tested on the International Space Station. In this experiment, researchers are looking into the use of a handheld sextant as a potential emergency navigation tool to guide spacecraft across the cosmos.
lines up a known star and a prominent landmark, and feeding his readings into the computer, gets his position back from the machine.
John's pointing right now at the sextant and a telescope, which are our navigation means to get home.
The International Space Station is designed to be a laboratory in space that can provide benefits on Earth and teach humankind what we need to know to explore beyond low Earth orbit in the years to come, including returning astronauts to the Moon in just a few years. There are a couple of recent experiments on the station that are building on all of those goals.
Cementing our place in space. Presented by Science at NASA. As your dog drags you around the block for his morning walk, you're probably not thinking about the wonders of the neighborhood sidewalk. But that concrete is pretty great. Next to water, it's the most widely used material on Earth. In the future, concrete may be equally useful off the planet, when humans construct a permanent base on the Moon. They'll need sturdy stuff that can weather bombardments from solar radiation and meteorites. No one wants a crack in their moon base. The key to making out-of-this-world concrete may be to study it out of this world. 2 experiments have taken place aboard the International Space Station, or ISS, to do just that. The microgravity investigation of cement solidification, or MIX, and Multi-Use Variable G Processing Facility, or MVP Cell 05. Researchers from Pennsylvania State University and NASA's Marshall Space Flight Center are analyzing the study's results. Concrete is a mixture of sand, gravel, and rocks glued together by cement paste made of water and cement powder. And it's not as mundane as it looks. Under the surface, it's quite complex. What goes on there is key to its strength and durability. Yet scientists still don't understand all the details of concrete's chemistry and microscopic structure. Processing methods aren't cast in stone. There's plenty of room for improvement. Alexandra Redlinska, principal investigator for both experiments, says, "Our experiments are focused on the cement paste that holds the concrete mixture together. We want to know what grows inside cement-based concrete when there is no gravity-driven phenomenon, such as sedimentation. It all begins when water is added to the cement. To put it very simply, the cement's molecular structure changes when the cement grains dissolve. Redlinska explains, as the old molecules dissolve, calcium silicate hydrate and calcium hydroxide start to crystallize. Myriads of these tiny crystals form all through the mixture, interlocking with one another and with the other concrete ingredients, such as gravel. The ISS experiments are researching how this all plays out in space. Redlinska says it could change the distribution of the crystalline microstructure and ultimately the material properties. The ratio of the water-cement powder is critical to making the concrete components combine effectively and determining the strength and durability of the final concrete. Will this ratio need to be different on the Moon, where gravity is about 1/6 of Earth's? That's the kind of question the experiment will shed light on. For the mix experiment, astronauts added water to a series of packets containing dry cement powder, then added alcohol to some of the packets to stop the hydration process at specified times. For MVP Cell 05, astronauts also hydrated dry cement, but for this experiment, they used a centrifuge on board the ISS to simulate gravity at a number of strengths, including lunar gravity and Martian gravity. For both experiments, the samples were returned to Earth for analysis. We're already seeing and documenting unexpected results, says Marshall's Richard Grugel, co-principal investigator for MVP Cell 05. Redlinska adds, what we find could lead to improvements in concrete both in space and on Earth. Since cement is used extensively around the world, even a small improvement could have a tremendous impact. We might even end up with better sidewalks for walking our dogs. For more from the International Space Station, go to www.nasa.gov/ISS-science. For information about other weighty matters, visit science.nasa.gov.
The astronauts on the International Space Station spend a good chunk of their time as lab assistants on experiments in a whole range of scientific disciplines. But they also devote time to sharing the experience of spaceflight with people on the ground, particularly when they talk with students and their teachers about science, technology, engineering, and math. In this installment of the STEMonstrations video series, astronaut and former classroom teacher Joe Acaba gets into the difference between kinetic energy and potential energy and demonstrates how one can become the other.
Welcome to the International Space Station. I'm astronaut Joe Acaba. Today, we're going to talk about potential and kinetic energy. Let's get started. Kinetic energy is the energy an object has because of its motion. An object can store energy based on its position. This is called potential energy. On Earth, imagine dropping an object from a raised position. As an object's altitude above the Earth's surface increases, its gravitational potential energy also increases. The potential energy stored due to its position is now being converted to kinetic energy. We also observe this with elastic potential energy.
Okay, new term. Elastic potential energy occurs when objects are compressed and stretched, or generally deformed in any manner, creating potential energy. Think of this bungee or a spring. Okay, Joe, what's next?
We pull back on the band and create potential energy. When we release the potential energy, it is converted to kinetic energy. Here on the International Space Station, we are still under the influence of gravity, primarily due to our position with the Earth. So when I have this ball on this ramp, normally back on Earth, I release the ball and it rolls down the ramp due to a change in its potential energy that's being transferred to kinetic energy. But as you can see, it doesn't happen here. So it doesn't mean we don't have potential energy. It just means we're not converting it at this time to kinetic energy. And why is that? Gravity is pulling us down, but we're moving super fast. And so what it is we're bending around the Earth in this perpetual falling motion. Thanks for joining me on board the International Space Station. We're sending it back to Earth so you can try your own experiment. See you next time.
One of the questions most frequently asked about life for astronauts on the International Space Station is a pretty basic one. How do you go to the bathroom in weightlessness? Late last year, astronaut Chris Cassidy took it upon himself to provide a quick answer to that question.
By far, the most common question we get asked as astronauts is how do you go to the bathroom in space? So, let's take a peek at the process. This compartment is called the WHC, a NASA acronym for Waste and Hygiene Compartment, I think. We just know it as WHC. It's inside this we call the stall, which is a couple of walls and a door that give you some privacy because you're right in the middle of node 3 with a treadmill on one side of the toilet, the weight machine we call ARED on the other side, and down in the floor our awesome window called the cupola. And this is a high traffic area, people are coming and going, so you need the privacy. First of all, the desire to go, the need to go is very similar as on Earth, where you just know you have to go. It doesn't feel any different because the fluid might be floating in your bladder or something. No, that's it. It's just the exact same sensation. You know you got to go. Either one, number 1 or number 2. So you've decided that. You float into the WHC. And we have the toilet, which consists of a seat and a metal bucket that we call a keteo, which is a Russian acronym for something, container of something. And but it holds about, depending on how many people are here, it holds about maybe 30 deposits. And we'll talk about that in a second. The urine goes into this hose right here, and this valve is what activates the whole system. Okay, these are the 2 primary control panels for the WHC. When the system is ready for use, it's a V. This means it's going to the UPA. So we say, check that it's V to P. All right, now we're on the inside of the hygiene compartment. Close the door so that you have your privacy. You take the funnel. This knob right here activates the whole system. It's very, very convenient because it's just one valve operates it all. But in the event that you forget how the system operates, or you're brand new here and you just want to double check, in good NASA fashion, we have a checklist. This is called Procedure 2.301, the WHC Nominal Operations Cue Card. And it's got several blocks for operations. So there's 2 different ways where the pee can go. It can just go into a bucket, which is called a YEDAVE, and essentially you're just peeing until that bucket's filled up, and then you have to swap out the bucket. Or you can configure WHC to UPA, and the urine processor assembly, and that way the urine is going directly into the system, and that's where we normally keep it. And it's most convenient for the crew members because you're not constantly changing out a tank. So there's a couple blocks to tell you how to make those changes, and some detailed steps if you need to know how exactly to do it. And in case things go wrong with the hardware, not yourself, there's a WHC malfunctions cue card, and we thought of all the different light combinations and the failure modes, but the bottom line is, if there's a red light, we talk to the ground, and together we figure out the path forward. Okay, back to normal operations. Time to go. You take the valve, And you turn it on. You hear the fan noise. Check for airflow. I'll show you that there is in fact airflow. So a little bit of airflow, and that helps everything flow in the right direction. We've got our simulator, and that's where your business goes. You're complete. You want to be a good crew member, so you make sure that you wipe off the excess. Use a disinfectant wipe occasionally or often, and then you simply turn the valve off. But I want to show you number 2 as well, so I'll leave it running and we'll roll right into that. Okay, when it is time to go, you flip this lever here and that lifts up the lid. The seat here is about 5 or 6 inches in diameter, and there's a plastic liner in there where your deposit goes. What I have here is green beans and mushrooms, and I do not like mushrooms, so I don't mind contributing this piece of food in the name of education. So pretend I ate this yesterday, and now it goes into there. You clean yourself, and the wipes go into there as well. You take this red tab, you pull it off the rim, and depends on how full the container is. This one's about halfway through. We do have a stick, and you push it down in there with all its other friends, and then it's time to put a new bag on. To put a new bag on, you pull that, it's like a hair scrunchie, and get it all so it has max capacity there, and ready to go. Close it up. Close the lid. Now you've gone number 1. Number 2, you cleaned yourself up, and it's time to turn the system off. You just take this valve, rotate it to off. The fan spins down. The system checks itself. All the lights go out, and you're done. So congratulations, you've just used the WHC for the first time, and you've learned about the process. Hope it's educational, but I don't think it's going to lessen the amount of times I have to answer that question. Thanks for watching.
Most of the astronauts who've spent time on the International Space Station, and those who've seen the Earth from hundreds of miles up for only a short period of time, say that the experience of looking down on the home planet has changed their perspective on, well, on a lot of things. For former astronaut Nicole Stott, art is the medium she's using to try to share the experience with the rest of us Earthlings.
The first time I saw Earth from space was on the space shuttle. My first flight, I flew to the station on the Space Shuttle Discovery, and I do not remember if we were over land or water or night or day. I just remember being impacted by the view. Like not believing, first of all, not believing that I'm floating in this place that I was in. You know, that was kind of amazing enough on its own. And then to be able to put my face in that window and see home below was awesome. It's like a work of art out the window there, and it surprises you every time you look at it. You get these beautiful twinkly city lights, you know, seeing where all the people are and where they aren't. And one of the most impressive things was watching thunderstorms, you know, storm activity moving around the planet. It's like watching neurons firing in a brain, these tentacles of light that are just connecting and traveling. Yeah, it might be starting over Florida, but it's moving across the ocean to Africa as far as you can see. And I remember floating there just thinking about, oh my gosh, everything is connected. And if you get it dark in the station, all the colors and the light come out in that depth of space as well. And it's kind of that, I don't really know what infinity is, but maybe that's what infinity is. And just like the clarity of looking at the Earth and the colors glowing there, you get that same clarity in this blackest black I've ever seen. And it feels like you could reach in and like the stars have distance between them. When you're in that place, 250 miles is really not that far in the grand scheme of things, but it seems far when you're in space on the space station or on the space shuttle. I think the perspective is one of like a reality check, of seeing this thing you thought you knew from being right down in it, on it, in a whole new way, and realizing that, oh my gosh, that is a planet, and I am farther away from it than I ever likely will be, and I feel like more a part of everyone, everything that's down there than I had when I was right in the middle of it. We all feel, I think, an obligation to share the experience in one way or another. For me, that's been art. I've tried to use the paintings that I create on my own, the work that I'm doing with other people artistically to share that message. And if I think about my own artwork, whether people like my art or not, really is not all that important to me, but I want to reach audiences that might not even know we have a space station, might not know that for almost 20 years, we have been living peacefully, successfully in space on this mechanically created life support system with people from 15 different countries doing work that is all about improving life on Earth.
If you want another look at any of the stories you saw here today, you can find them all on YouTube and Facebook. They're there along with lots of other great features on a wide variety of NASA topics. Now, if you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast. That's our weekly show talking to folks involved in all areas of space exploration. Today, Gary Jordan sits down with the lead flight director and the ascent and entry flight director for the Artemis 1 mission to get into the details of what's on the plan for NASA's upcoming flight of the Orion spacecraft bound to orbit the moon. Go to nasa.gov/podcasts for this week's episode and all our previous episodes, and the full library of all the NASA podcasts too. You can find them all on Apple Podcasts, Google Podcasts, and SoundCloud.